We've dealt with area of a triangle before, but area of a triangle always had to deal with 1/2 base times height. And this height was the difficult part, because you have to be able to find the height of your triangle, which was this altitude part, and it's not always easier said than done. And so another way we can find area is by multiplying a times b, or any two sides, and the included angle. And so area is 1/2 a times b times the sine of the angle that's in between them, rather than using this 1/2 base times height. So, ABC, finding the area, A is 10 across from A, B is 14 across from B, and C is 46. And so I'm going to do the area is equal to 1/2 A times B times the sine of the angle in between them. And we'll say that's C. Notice that the angle has to be in between them, otherwise you have to find that angle. So 1/2 10 times 14 times the sine of 46. And so the area (1/2) times 10 times 14 times the sine of 46 is 50.4. And that's square units, because you're dealing with area. Now, if you had centimeters, could have put square centimeters, things like that. Another one, triangle ABC. A is 66 degrees, side A is 20, and side C is 16. Now, the problem is that we have two sides, but we don't know the angle in between the two sides. And so, you need to find that angle. And so we have law signs that we could use to find angle C first, and that's what we're going to have to do. So angle C, sine of 66 over 20 is equal to the sine of angle C over 16. And so 16, if we multiply both sides by 16, to cross out the 16 on the bottom, 16 times the sine of 66 over 20 equals the sine of the angle C. So 16 times the sine of 66 divided by 20, 0.731 is the sine of the angle C. If you do inverse sine of that, you get 46.9, or 47.0 if you round up. 47.0 is angle C. So because we have the sine, you always have to double check 180 minus your angle, 47. So you could have another possible triangle with a 133 degree angle in it. However, if you add that plus your 66 that already exists, that's not possible because you're already past 180. So we still only have one triangle possible. And so we've got 47 degrees here. So to find that leftover angle, 180 minus your 66 minus your 47 leaves 67 degrees here. For your leftover angle B. So we have to do a little work before we could actually find the area, which is 1/2 your two sides, 16 times 20, times the sine of the angle that's in between them, 67 degrees. The biggest thing is that we have to find those first. And so we're just typing it in, and we get 147.3. and that's the area. And that's square units again. Now, sometimes it's annoying to have to find that leftover side or leftover angle. And so another formula that we can use for the area is called Heron's area formula. And so we have S and A, B, and C. A, B, and C are the sides, are side lengths. And S here is called the semi-perimeter, or the half perimeter. So if you have all three sides, 8, 11, and 5, you can find S by doing 1/2 8 plus 5 plus 11. So you've got 1924, or this was 13 plus 11 is 24, divided by 2 is 12. So that's your semi-perimeter, half of your perimeter. So then the area is equal to the square root of 12 times 12 minus A, 12 minus B, 12 minus C. I don't even care what your sides are, just get all of that subtraction in. 12 minus 8, 12 minus 11, and 12 minus 5. So 12 times 12 minus 8 is 4. 12 minus 11 is just 1. 12 minus 5 is 7. And so we're getting all of that in there. 12 times 4 times 7 is the square root of 336. And so the area is the square root of that, 18.3 square units. And that's the area of that triangle. Law of sines and the area of the triangle using 1/2 AB sine C and Heron's formula. Sometimes a little work, sometimes it's as easy as just plugging it right in.